Okay, Assalamualaikum and good evening. Good afternoon. We're going to start with the complex system. Today we're going to study about the type of systems. Okay. This is the first one is we call the isolated system. Why it is important for us to understand the type of system? Because we want to make sure that we understand the system as it is, as a package, as a system, their interaction with other systems. So in this world, whatever subject we're talking about, is it economics, whether it is economics, or whether it is international politics and international relations, or whatever, there is a system and other systems, the interactions between or among them, in addition to interactions within the particular system. That's why we have to understand the type of system. The first one is that we have this isolated system. Imagine a thermos. Thermos is an isolated system because you put the hot water inside that can last for maybe 10 hours. Yes, isolated system, almost completely, because after 12 hours, the temperature is no longer as hot as before. So isolated because we're talking here about, number one, energy cannot enter or leave. Yeah, on my right here, energy cannot enter or leave, isolated. And matter also cannot enter or leave. Matter, things cannot go in or cannot go out. What outside cannot go in, already inside the water cannot go out. So matter cannot enter or cannot leave. Energy cannot enter or cannot leave. So it is isolated system. And next we have to go to this telegram. So a closed system. Yes, a closed system. Here, matter only cannot enter or cannot leave, but energy can be exchanged. A closed system. Earth can be approximately or a closed system, because matter cannot go in roughly, but of course water can get inside. But energy can be exchanged. Oh. Where is it? Oh, yeah. That's a closed system. Isolated, Earth, if is approximately a closed system. There's a radiation from the sun, so energy can be exchanged approximately. Okay, energy can be exchanged. but matter cannot enter or cannot leave approximately. So there's a closed system compared with the now isolated system. Everything, matter and also energy, cannot enter or cannot leave. So that was the first one, isolated. Closed system, matter cannot enter or leave. Energy can be exchanged. We're gonna see what does it mean by the word exchange. So that's example. Earth, approximately the second type, a closed system. This is biology, and amoeba engulfing its food is an example of an open system. The third type of system is one which is free to exchange both matter and energy with the external world. It is an open system. A city, for example, is an open system. A city. This is a town or city. An open system. Matter can come in, products, lorries of goods coming in and out. Matter. Energy can be exchanged. So town or city is an open system. Again. And this is important for you to understand the interactions of system. We're going to study here in this course actually is a complex system. We only focus on one aspect only. What is the system that is available or existing, or the concept that terminology we use here, that self-organize, organize into an emergent property or an emergent characteristic that makes a certain place, certain location as the place that become the birthplace of technology. So we're going to study complex system, the theory, to understand innovation that takes place at a certain geographical location. For example, Silicon Valley and R&D center, to understand what occurs there that makes that place become the birthplace of many technologies. So it's gotta be their interactions. So when we talk about system has elements, unsur-unsur, parts, elements, parts, the same thing I'm talking about. Elements, I call it sometimes elements, sometimes parts, that are interacting among each other within the system. Within the system, for example here, this in the city, there are interactions among industries, basically broader interactions among the consumer, suppliers, and so on. So if we imagine this is only part of the city, Silicon Valley, for example, so what goes inside there? We want to understand, and that understanding we want to analyze using the complex system. So when we study about the system, we also study about a number of system terminology, system theory. Among them is chaos theory, because we're talking here about non-linear results of the interactions. And this understanding the system takes into account various fields, including thermodynamics, including biology. Look at this from thermodynamics. This is everyone understands. Heat conduction in a bar. If you put a heat on one side, on this left side, T, A, you hit it there, put the fire there. This is going to be the temperature at the beginning, and finally it will settle to that temperature like this, the graph, final state. So a system will periodically find a stable state, homeostatic state. Until another force, major force, will occur again, it's going to find another final state at different level. And it is an irreversible process. Imagine what is irreversible process. Look at this. Example might be the mixing of gases at two different temperatures. Figure A, two different temperatures, the mixing of gas we separated by something in the middle, two different temperature 1 and temperature 2. We suppose that the system is isolated, so that in this case we can have all this, but finally it will come to this. Once we take out the separation in the middle, and that is an irreversible process. What is irreversible? I think immediately of plastic surgery. Plastic surgery is very popular, but mistake can happen, and it is irreversible. You cannot go back. Once you do the plastic surgery, you cannot go back to your original. I think that I hit the point. Irreversible. Even though doesn't fit well with the example that we're studying, but that's the fact of irreversible. In this case, the system once occurred with a new property is not going to reverse back. 1 plus 1 plus 1 is not 3. 1 plus 1 plus 1 is 21, for example, 21. But if you want to break up again that 21, you cannot go back to 1 plus 1 and 1 and 1. 3 items, no, cannot. Once another characteristics or property, characteristic that emerge, it cannot be reversed. That's one of the main characteristic of complex system. For example, here we must explore microscopic meaning of. There's another one. Entropy also we have here. Entropy. We return to the consideration of a gas or liquid and inquired what entropy may mean in such a physical system. It was Boltzmann, 1872, who first pointed out that entropy was a measure of molecular disorder. So in terms of today's complex system theory, we're talking about information. In this case, molecule. Today, more and more on data, information, disorder, and therefore that the law of entropy increases. The law of entropy or information increase was simply a law of increasing disorganization. Let us take a simple example. Consider a container divided into two identical parts by a permeable partition. So once we take out that partition, the distribution. And then this critical chaos theory, which is part of the complex system, we can imagine with the block A, B, and C. Block initially in unstable stationary state. A, which is unstable, move away to a stable state of C finally. So one second. I'm also checking the YouTube broadcast. Oh, you know. Oh, it is streaming. Okay, next, I think I'm gonna stop at that.